day. What are we supposed to see today?
When the wind blows, how the sand moves and how it builds up in a certain place. And also on the other one is where we're going to put water in it, and it's going to show how the water, the water moves the sand and how it changes the way it looks.
Welcome to WISD's 4th grade science camp. This is the first time that we have a science camp for our 4th grade students. They're experiencing science. Some of our science stations have integrated math and integrated literacy to make it more of a learning environment. We normally do this for 5th grade science students as they prepare for the STAR assessment. We felt that it was very important for our students to get the experience in the lower grades, since the STAR assessment is a comprehensive assessment. So today we have activities that students are constructing meaning from the science, but these standards are aligned from their grade level all the way to 5th grade, since that is where they're assessed. We're hoping that next year we have the same thing for our 3rd grade or 4th grade students as well. And in the future, we hope to have this for K through 2nd, where they're actually making meaning of the hands-on science that they're doing.
It takes about 1 month for the moon to travel around the Earth. Remember, what did I tell you? How many days does it take for the moon to orbit the Earth?
The hands-on is going to help them to retain that information, because once they hear it, and not everybody can learn by just hearing auditorily, but when they actually go on, tactile, hands-on, it helps them to retain that information for much longer. The other thing that's very, very important is that students realize that, hey, learning is fun.
Why is it that we see our pencil more different in my corn syrup than in my water?
The rationale behind all of this is that the new state curriculum, okay, the STAR, is driving the STAR assessment, which is a new concept in terms of the amount of information that is available out there. There's a lot of information, tremendous amounts of information, and the concern is that students are not capable of learning all of it. And so what we're going to do, the state has come up with a depth of knowledge. Teach fewer concepts, but teach them very well so that students can use this information to be able to adapt and learn other information. Believe it or not, if you try to teach too much, there's an overload. But if you establish a foundation and students truly master certain objectives, then from there, that's a springboard for them to learn. So at the end, it's better to learn fewer concepts, but master them, and you'll learn more because you'll expand, versus in trying to learn too much at the same time.
Right now I need you to put your folders to one side. We've got a plan for each student.
We do hands-on. The kids are able to graphically touch, see, and do and compose the activities that they need to do. And as they do that, the research shows that information stays longer with them throughout their lifespan. So we really, really believe in our hands-on activities, because these kids will be able to carry that to the rest of their high school careers and in their future college careers.
Now, on the count of 3, I'm going to put my timer. We're going to chew for 3 minutes, okay?
In this particular activity, the students are doing a science hands-on lab where they're using tools to measure the mass of a bubble gum. As they chew the gum, they notice a decrease in mass. So this is a readiness standard. It's tied into other grade levels, but the way that the state is now ensuring students learn the information is that it's a process skill with a science concept. So the student has to know how to use the tools, for example, the triple beam balance. They have to know the science, so they have to know a little bit about matter, what's going on with the mass, know about how the sugar is dissolving, and the kids are using those process skills at the same time that they're learning the concept.
When you get to your new moon, you're going to go through all the phases once again, okay?
In this particular activity, you notice that they're learning about the moon phases, but they're learning the moon phases through a literature book. So, as I mentioned before, we also have teachers here going through the stations, learning the activities, and we want them to understand that even though it's 4th grade and 3rd grade, you can, and let's say you're a reading teacher, you can still teach science. Although it's a literature book, you'll do the reading portion, but then you do the hands-on science. In 3rd and 4th grade, the students should already come back with the background knowledge of moon phases, as far as knowing the pattern of the moon phases. And now they have to understand, well, here are the moon phases as I see it from the Earth. But at the same time, they need to know, well, these are the moon phases as seen in the universe, from the universe. So they need to know how to understand the moon phases from both angles. But in this particular case, as I mentioned before, we try to integrate literature. In one of the stations before this one, we integrated the math so that students understand how, when you go into the real world, you have to use your math, your science, your reading skills to make a problem-solving strategy. So we're trying to make thinkers out of our students.
Now, when it comes to the photosynthesis, it's going to be creating and making the food from the leaf.
As you can see, the students are working on the plants. In the lower grades, for the most part, the students understand the parts of the plants. But as we've seen them, the students going to 5th grade and they're being assessed, the standard says that the students need to know the structures and functions of the parts of the plants. So our goal here is for the students to understand the structures and the functions of each of the plants. Now, as I mentioned before, they do plants in the lower grades, but we do notice a lot of, okay, the teachers teach, we're gonna plant a seed and we're gonna observe it grow. But you hardly see students working with a plant, a full-grown plant, which is what you have right now. And you have the soil, the roots, the leaves. They see the whole entire plant already, which is what the students need to observe and to see, oh, this is where the nutrients are absorbed in the soil, and they can actually see that. So now they're drawing what they're observing, but they're also recording the function of these parts. You know, they have important functions in order for the plant to survive, which is the most important thing that these students need to know. So sometimes as teachers, we'll teach certain things, but we have to go to the standard to understand the in-depth that our students need to know about that topic. So it's not just about a plant, it's about what it needs for survival. And that is our goal in this station. And it seems like something so simple, but this is something that the kids hardly get to do in their everyday life, believe it or not. So, and that is why they're recording and documenting and taking things back with them.
What the student learns, a lot of it depends on their interaction and a lot of problem solving and experimentation. So where they actually see something that happens, and a lot of it is theory also, because they're going to form their hypotheses and say, well, you know what, I think that this is going to happen. But then when they do the activity, they'll actually begin to see whether it happened or it didn't happen. And that's again the hands-on type of activities that science is so well known for.